As we start Chapter 2, we'll be using many of the items we went over in Chapter 1. So building on it, our objectives is to solve linear equations using properties of equality, solving linear equations that can be simplified by combining like terms, solving linear equations containing fractions or decimals, and then recognizing some special kind of equations that are referred to as identities, and things that look like equations but have no solution. These are called contradictions. So with that in mind, let's get started. Solving linear equations using properties of equality. Well, they give us some background information here that we'll skip over for now. Later we'll be looking at some graphs in Chapter 3. But they give us a word problem to start with. It says to find the increase in the number of Wi-Fi enabled cell phones in the United States from 2014 to 2015. Let's look at this equation below. And we know it's an equation because there's an equal sign in it. So the increase in cell phones, we're letting X stand for that, is equal to the cell phones in 2015 minus the cell phones in 2014, and it comes out to be X equals 11. So again, what we're saying is on one side is equal to what is on the other side. And I have a little example that I always like to share at this time. And you can sketch this in your notes as well. If you have a scale that has a fulcrum in the center, and the weight on one side is equal to the weight on the other side, the scales are going to be balanced. Now, if you take off weight from one side, then it's not going to balance anymore. But if you take off that same weight from the other side, even though it's not the same as it was originally, it's still balancing. And that's what we do in an equation. We do various things to both sides until eventually we end up with, on one side, let's say what's left there is the letter X, and on the other side is the number 3. So we say that X equals 3. And that's basically what an equation does. And then we use various techniques to eventually get to X equals 3 algebraically. Now, there are different types of equations. The type we'll be studying in this course are linear equations. Right now, in only one variable. So here we see equations because of the equal sign. There's expression on one side and on the other. And since the value of X is only to the first power, or Y to the first power, n to the first power, that is a linear equation. If your variable is only to the first power, these are linear equations. Now, in a later course, you'll study equations that are to the second power. And we touch on that just a little bit. These are not linear equations. This type of equation is called quadratic. But we will just be studying linear right now. Now here they're introducing what is called the rule or the general formula for a linear equation in one variable, which is ax plus b equals c. And what we'll do through various procedures is to isolate this x. Now, looking at the textbook, and again, I'm not going to read it particularly, but comment a little. They give you some of the background that I'll be explaining, and I've talked about this already, that eventually we're going to have x equal a number. And we're going to start off by adding things to both sides and later multiplying both sides and dividing both sides by certain things. And those series of steps are the steps we take in solving an equation. So let's go on to an example, and of course you can read the textbook. It has a lot of detail there as well. So there's a very simple equation. This is example 1. We want to isolate this x. So in order to do that, we have to use the rules to get a positive 5 out of there. Well, in chapter 1 we said if we subtracted 5 from both sides, we then get 2x, adding them up. This is a 0, and this becomes a 4. So we've eliminated the 5 on this side by doing the same thing to both sides. Now we have a 2x equals 4. We want to get the 2 out of there and not with the x anymore. And we do that by dividing the 2 out, because this is 2 times x. So we divide the 2 out on both sides. Here it cancels out and we get x equals 2. And that is our solution. So we started with an equation. We did some things to both sides. This was, in a sense, subtract. And then we divided both sides by the number that goes with the x. This is called the numerical coefficient of x. And we've solved that equation. Now if you put the 2 where the x is, that is 2 times 2 is 4 plus 5 is 9. And 9 equals 9. So you did a check and it proved that that was true. All right, now fortunately in MATLAB we just put it in MATLAB and we can see if we have it right or not. Now here we have an equation with decimals. So they're keeping the decimals right now, which we could do, and let's follow this one. So I just copied it carefully. I want to isolate the c term on this side, so I will subtract 2 from both sides. And here I get 1.4 equals a negative 3.5c. Now, in order to get the c by itself, I divide by the numerical coefficient of that term, which is a negative 3.5. So here these cancel out, and negative divided by a negative gives me a positive 1c, which I don't write the 1. And then when I do this division in my calculator, I get 0.4, and I forgot to bring my my negative sign here. So this is actually then a positive. And that's why you need to be careful of the signs. And in your textbook they have it worked out nicely here. And they tell what they're doing to both sides in the solution. Very useful. Now in example 3, they're starting to get a little more challenging. But again, we're going to collect like terms. So on this side we have a negative 4x and a 5x, which just leaves me with an x minus 1. And on this side we have a 9x minus 7x, will leave me with a 2x plus 3. So here's where we want to get, eventually in most equations, a variable, a number, a variable, a number. Now we want to get all the variables on one side, and we're going to try to keep them positive. Now the solution here, they let it be negative. But I'm going to move or subtract an x from this side, subtract a 1x from this side. So this just gives me an x here on this side that's positive. And I'm going to subtract 3 here and subtract 3 there. Remember, these canceled out. I added this up, got x. Subtracted 3 from both sides, I now get x is a negative 4. Now notice my x is on this side. Over here it was a negative x equals 4. Well, how did they get it to be a positive x? Well, when you have something like this, you can divide by a negative 1, both sides. It's a funny looking 1. That's what they're doing here. And that just reverses the sign. Now, by keeping my x positive here, I didn't have to worry about dividing by a negative. X is negative 4. Notice the answers come out the same, and it checks. Now another type of thing you run into in solving equations is where you have a parenthesis. So one of the rules is to get rid of grouping symbols, which is what we see here. And we use the distributive principle to do so. So we get 2x minus 6 equals 5x minus 9. So again, we have a variable, a number, a variable, a number. We want to get all the variables over to one side. So I'm going to do so by subtracting 2x from both sides. Again, I want to keep my x's positive if I can. So this is 3x. Now I want to get this 9, negative 9, on the other side. So I'm going to add 9 here. So I end up with a 3. Now, to get the x by itself, I'm going to divide by the numerical coefficient, which is a 3, both sides. And since it's positive, I'm not too concerned about the sign. This will be x, and anything divided by itself except 0 is 1. And that's what they had. Now notice in the book, they're showing that they did it the other way and ended up with a negative. So they had to divide both sides by a negative 3, and the answer checks out the same. But I like to keep my variables positive. Now, this next series of equations are very, very important to make your work in the future so much easier, and that is solving linear equations containing fractions or decimals. And the basic rule is to get rid of the fractions by multiplying each term by the least common denominator. So let me set that up. So I just copied it so we can work with it. Now, looking at our denominators of a 3, a 4, and a 6, what would be my least common denominator of all of these? Now, we're not looking for a factor, we're looking for a denominator. If we were going to add these up, what would our least common denominator be? And the answer is 12. So I'm going to multiply every term by 12. And this is one term, this is one term, this is one term. So 3 goes into there once, 3 goes into 12 4 times, 4 goes into there once, 4 goes into 12 3 times, 6 goes into there once, 6 goes into 12 twice. So now that all my denominators are 1, I don't have fractions anymore. So I multiply through, I get 4y minus 3y equals 2. Now I combine like terms, I get just a y equals 2. So this could have been quite difficult, trying to deal with all these fractions, but by multiplying each term by the lowest common denominator, I made it so much easier. So here's a series of steps. If we wanted to summarize them, we could say the first rule, get rid of fractions. Second rule, get rid of grouping symbols. Third rule, combine like terms. Fourth rule, get all of the variables on one side equal to a number on the other side. Now, one of the words we'll introduce here shortly is called transposition. Now, transposition takes a term from one side and just moves it over to the other, and you change its sign. Then we'll use the multiplicative property of equalities to isolate the variable. We want to have just a 1x left on this side, and that equals our answer. And then we check it. And then for us, we could use MATLAB. And on a test, you could actually put your solution into the original equation, or be careful to check your work in the signs. Let's go on. Now in example 6, I'm using this room up here to write it out carefully. Now notice I put this in parentheses, and there's a negative sign out in front. But how many terms do we have here? Well, this is one term, this is one term, one term, one term. Remember we said terms are separated by a positive or a negative sign. And then if they're on either side of the equation, the equal sign, then this is an expression, this is an expression. But we want to get rid of all our fractions by multiplying each term by the lowest common denominator. Now remember, this one's already have a denominator of 1. So our lowest common denominator is 8. So I have to put this in parentheses too. Okay, now I start multiplying here. 2 will go into 2 once, 2 into 8 4 times. Well, I didn't write my 8 by every term either, so I better do that. 2 will go into 2 once, into 8 4 times. Here there's no cancellation, but here the 8's cancel out completely. So now there's a 1 under each of our denominators. But now I have to get rid of this parenthesis. So 4 times x is 4x. 4 times 5 is plus 20. Now this is just a 4. This is going to be 16x. Now here we're going to use the technique. A negative sign in front of a parenthesis. We remove the parenthesis and change both signs. So this will be a negative x, and this will be a plus 3. Now what do? We collect like terms. We get 4x plus 20, 4x, 20 and 4 are 24, equals 15x, combining these two, plus 3. Now I want to keep my x's positive, so I'll change color so we can see it better. This will be a negative 4x here, negative 4x there. So this is going to be an 11x. Oh, I had someone ring our doorbell there. Anyway, continuing, we're going to subtract now 3 from both sides. So this is 11x, this was 0, this is 0. Now this is going to be 21, and this is going to be 11x. So now we divide both sides by the coefficient of the x, 11. These cancel out, and we get x equals 21/11. Again, quite a series of steps as they get a little more challenging, but this showed all of the steps. Get rid of fractions, get rid of grouping symbols, combine like terms, get everything over to one side or the other. And again, I like to keep the variables positive, and then you divide by whatever is with the x, usually. All right. And once again, in your textbook, you see all of the steps worked out, and then the criteria, the rationale for doing each step. Now, in example 7, as we look at it, here there are decimals, and decimals are a form of fraction. So, to make our work a little easier, if we were to get rid of all our decimals, that would be making your work easier. And we start off by looking at, well, how many terms do we have? Well, this is one term here. This is one term. This is one term. And this is one term. So we have 4 terms. And then we look and see how many decimal places. Well, this one has 2. This one has 2. These only have 1. But I could easily add a 0 there. And I could easily add a 0 there. I left some room for that. So now each of our decimals has 2 places. Well, what technique can we use to get rid of 2 decimal places? And as you see, they're multiplying every term by 100. Now, the easiest way to multiply by 100 when they're in decimal is just to move the decimal place over 2 places. Now that I have 2 places here, it's easy to do. And here, these already had 2 places. So now I rewrite my equation without the decimals. So this is going to be 30x plus 10 equals 27x minus 2. So now I'm going to get all my letters on one side by subtracting 27x from both sides. And that's going to give me a 3x there. These just cancel out. And here I'm going to subtract 10 from both sides. And I'm going to keep my equal sign sort of lined up. And this is a negative 12. Now to get x by itself, I'm going to divide by the numerical coefficient, both sides, and I get x equals negative 4. And I didn't have to worry about the decimals. This is one of the techniques. And this is cute since we have a little time. What's wrong here? Well, 3x minus 5 equals 16. Well, can you see what they did is they subtracted 5 from 16 to get 11. You don't. You're supposed to add 5 to both sides. So this is supposed to be 21. Okay. Anyway, they're kind of cute. Keeps you on your toes. Now in this next objective, objective 4, we want to look at and recognize identities and equations with no solutions. Okay, so looking at this, can you see that this side is exactly the same as that side? So if we subtract 2x from there and 2x from there, we get 2 equals 2. Is that a true statement? Yes. And this always happens when you have an identity. That is, one side equals the other. Now, what is the solution then for this x? And in a sense, this x? Well, you can put any number that's the same on both sides, and that would be a solution. So we say for this, when you have an identity, the solution is all real numbers. And they sometimes use this symbol of a double R that stands for all real numbers. Now, this one looks like an equation because it has the equal sign. But when I subtract 2x from both sides, I get 5 equals 1. Is that a true statement? No. So when this results from something that looks like an equation, this is what is called a contradiction. And there is no solution for a contradiction. No matter what you put there and there for the x, will never make that true, because 5 does not equal 1, or whatever occurs. Now when you look at it, you don't know quite what you have, so let's do one. So it starts off looking like an equation. This is example 8. So we clear parentheses. We subtract out our x's and we get 5 equals 6. Is that a true statement? No. So, for this one, this is a contradiction. There is no solution. Now in example 9, this looks like an equation. Let's see what we get. 6x minus 4 equals 2 plus, clear parentheses, 6x minus 6. 6x minus 4 equals, combined like terms, 6x minus 4. Oh, we have an identity. So if we were to subtract out the 6x's from both sides, we get negative 4 equals negative 4. Is that a true statement? Yes. So that means whatever value you put there for the x, and that same on the other side, is a solution. So this is all real numbers. Or we use that special R here. Now I might mention here they also cancel out if you add 4 to both sides. You get 0 equals 0. That's still a true statement. And that's what they're showing here. But you don't have to go that far. Once you have something equals what's on the other side, and there's no more letters, that's all real numbers. And there's that double R there. Once again, at the end of the section, there are vocabulary words, readiness, there's a video check, and of course you'll be doing your study plan, practice and quiz bees. And I hope you did well on your first test.